Hi everyone, my name is Daniel Genkin. I'm a software engineer here at Microsoft, and today I want to give a little presentation of how we use AI and agents to improve on-call engineer efficiency and mitigating service level incidents. So here on your screen, you can see a little sample incident, something we might see in production where we see there were some nodes that were running and one of them has failed. Looks like it might have been a service or null reference exception, sorry. And so in these sorts of incidents, we'll see the on-call engineer has to now figure out what is the issue and has to fix it. And we want to do it as fast as possible, obviously, to ensure that we have the minimal effect for customers, if there even is any. The primary tool engineers have is something we call troubleshooting guides, or TSG for short. These guides essentially outline what to do and how to do it. As engineers work through those guides, they'll post into the discussion. So as you can see here, there was some logs posted. We can see there were some users connected and things like that, and there was some discussion about what to do. It looks like restarting a node was decided upon, and ultimately that resolved the incident. So this is the general flow of how it works. But sometimes, like for example, here we saw the logs, there's new knowledge that is discovered. So maybe some bug that we didn't know about before, or maybe there was some code changes that caused slightly different behavior. So all these things have to be documented in the troubleshooting guide. And obviously, as we always are adding new features and capabilities, these troubleshooting guides have to be updated quite often. The problem arises when these troubleshooting guides get out of date. And unfortunately, it happens a little more than we would like. So we started using AI to help improve this process. To do this, essentially, we let the AI write the TSG and ground it on existing TSG knowledge. So the way we do this is we have this little tag we add here, and then this would ensure that in the background, the system that's running can pick up this TSG, this incident, sorry, and convert to a TSG. Switch over to VS Code so I can show you what those look like. So here is a sample. This was created actually for that incident with the information that's in there. So as you can see, create a little summary, outline the impact, root causes, some of the monitors that were affected, and then even some useful queries that I found that could be used to find what is the issue and how this works. So for example, like those logs that were posted, and then it also outlines how to mitigate the incident. So some commands that an on-call engineer could run, and ultimately this restart command, which would restart the node and hopefully end up fixing an issue like it did in this case. It also references some useful other guides and things like this. Now, this is a fantastic document, and it's going to be continuously updated as new details emerge about that incident or as similar incidents come in. And this ensures that the engineers don't have to do anything. It's just automatically updated. But this could be a little bit of a long document sometimes. So beyond creating this document as a general overview, we also integrated it with Microsoft Copilot. So if we open up the Copilot, I already asked the question. Here we can see that it actually indexed that file. And you can see here, it was outlining that this sort of incident can happen, common causes, right? Some other stuff that we could use to fix it, even a little bit of some context code, and then even reference Stack Overflow and a couple other public-facing documentations and discussions that might have happened to give the engineer some more context on what this sort of issue is and how it can be fixed. And lastly, it even linked this email that we can use to then get some knowledge about how this was handled in the past. All right, so this takes that TSG and augments it with extra information and presents it in a more digestible way so that the engineer can take action more quickly. And going forward, we're going to take this a step further, and we want to use agents and the computer use APIs to actually allow the AI to check dashboards and do these queries instead of just presenting them. And that'll give the engineer the information they need to then just press approve, and then the AI can go ahead and restart the node for the engineer, right? So this will make this process even faster and even further improve efficiency and ensure that there's even less downtime and even better experience for the customers in that. But yeah, so that's a little bit of overview of how we're working on this, so where we're going with this. If this sort of topic seems interesting to you, please check out the Future of AI blog series we have on the Tech Community website. There's a blog post in that series about this stuff, and it has a lot more details about how it works and what we're going towards, as well as many other topics on how to use AI and agents for your workloads. Thanks for listening.